Welcome to the video for 11.1. We're talking about space figures and their cross sections. New word for today, polyhedron, is going to be the type of figure that we're going to be looking at this chapter. So we're talking about 3D shapes instead of 2D now. So a couple vocab words for you to fill in there. So we have polyhedron, like I said. That's a space figure or a three-dimensional figure whose surfaces are polygons. That's an important part of that definition. Every side of the shape has to be a polygon, so something that's at least a triangle, okay? We call each surface, which is a polygon, each polygon is called a face of the polyhedron. All right, and then we have a couple other words. An edge is a segment that is formed by the intersection of two, so that's this area right here. And then you have vertices. So a vertex is a point where three or more edges intersect. So any point where some segments or some edges are coming together. Okay, so that's just a little bit of vocab for this chapter. We're going to talk about finding how many of each there are, and then we're going to throw a couple other things at you today. So a lot of the worksheet today might just be listing how many vertices, edges, and faces there are. So vertices, edges, and faces. This one does say to list them, so we will make a little list as we go as well. But the vertices, so over here we have a pyramid. It's called a square pyramid. We'll talk more about that later. The vertices are all the points where three or more lines intersect. So these 5 spots, there are 5 vertices in this pyramid. A list of them would just be the names of those points, so D, E, F, G, and H. For edges, that's all the lines that you see. So we have a line on each on the bottom there, and then we have a line going up to the top from each vertex as well for a total of 8 edges. So we could list those as well in the way we just had done it. So you can go around the bottom first. We have D, E, E, F, F, G, and G, D on the bottom. And then we have E, H going to the top. We have F, H going to the top. We have G, H, and D, H. And again, you can have any of those letters reversed if you want. For faces, it's just how many surfaces there are. So we have the bottom square, and then we have 1, 2, 3, 4 triangles surrounding it, for a total of 5 faces. All right, so again, that's going to be 4 triangles. So we have triangle HED, we have triangle HFE, which would be like the right-hand side. We have triangle HGF, which would be like the back. And we have triangle, what did I miss? The left-hand side, so we could call it HDG. And those letters can be different. And then on the bottom we have a squared. We could call it D, G, F, E, or some other ordering of those letters. All right, so you're going to try that again. So on this next one, same thing. Make a list of vertices, edges, and faces. See if you can get the right total for each and make a little list of them. And then click resume when you are ready. All right, so here's some answers. You should have got 6 vertices. You should have got 9 edges and 5 faces. For the vertices, it's just all the points, all the letters that you see. For the edges, there should have been 9, so maybe that was one of the tougher ones to count. Edges should be your biggest number each time. But what you have is 3 edges on the front with the triangle, 3 edges on the back on the triangle, so that's up to 6. And then we have 7, 8, and 9. So if any of your letters are in a different order, that's all right. And then for your 5 faces, you have 2 triangles, one on the front, one on the back, and then 3 quadrilaterals connecting those 2 triangles as well. So you can just check your work there and see how you did. One thing that can make this a little bit easier, here's a blank for you to fill in. Euler's Formula can make this a little bit cleaner, a little bit faster for us. All right, and it's just a formula. If you notice what we had over here, the first problem we had 5 vertices, we had 5 faces, we had 8 edges. All right, so if you add the faces and the vertices together, you always end up with how many edges plus 2. So that would be 10 equal to 10. All right, same thing with this bottom one. We would have that 6 plus 5 equals 9 plus 2. So Euler came up with that formula. It's just for a quick way to make sure that you counted everything up correctly. The number of faces plus the number of vertices will be 2 more than the number of the edges. So there's 2 less edges than there are faces and vertices added together. So there's this 2 more relationship. Okay, so we're not going to list it every time, but we can check vertices, edges, and faces. Okay, vertices is a pretty quick one to count. They're going to happen where 3 or more lines run into each other. So we're going to have 6 vertices on the top because this is a hexagonal prism. We're going to have 6 vertices on the bottom. So that would be a total of 12. And then faces is pretty easy to count. We have a face up top and a face on the bottom. So that would be 2. And then so since there's 6 sides, there's a quadrilateral that's going to connect each of those sides. We have 3, 4, 5, 6, 7, 8 faces on this hexagonal prism. And then we have edges. So there's going to be 6 up top. So same 6 on the bottom. That's up to 12. Then we have a line or an edge that's going to connect the top and the bottom 6 times. So 13, 14, 15, 16, 17, 18 edges. Okay. If it says to verify Euler's formula, remember that's just F plus V equals E plus 2. All right, so if we have 8 faces and 12 vertices, that should equal the amount of edges, 18 plus 2. So if it says to verify, we're just going to check that real quick. 20 does equal 20, so we must have the correct answer. Okay, they might even give it to you where you can't see the whole shape. So since we can't see the backs of these shapes, we can't just count it up. So we're going to rely on Euler's formula to help us figure this out. We're just going to trust it. So we don't know what F is, but we know that there are 20 vertices and we know that there are 30 edges. So we know that F plus 20 equals 32. If I subtract 20 from both sides, I end up with F being 12. There must be 12 faces on this polyhedron. Same situation over here. I don't know how many edges are on this, but I know that F plus V equals E plus 2. Some of the numbers are going to repeat a little bit for this example. I know that there's 20 and 12 of faces and vertices. That's equal to the amount of edges plus 2. So I know that 32 equals E plus 2, or 30 has to equal the amount of edges. Okay. So Euler's formula is F plus V equals E plus 2. That's if the shape is all put together. What we're going to talk about next is what if they are split up. So that's where we'll resume right here. If we have a net instead of a put together polyhedron.